States of Matter, Water Phases by Chris Graves. Hi, this lesson is on different phases of water. As you know, water exists as drinking water, or water you can swim in, and it also exists as ice or frozen water under certain conditions. And last but not least, it also exists as steam. Steam is a certain form of water that exists under great or much higher temperatures and also at different pressures. Depending on the pressure or the temperature, water will exist in any one of these three phases: frozen, a gaseous state as steam as shown here, or in a liquid form, which we are all most familiar with. Hi, I'm Chris Graves, and our project is on states of matter, specifically water, and how it changes states through different phases depending on temperature and pressure. And I have two teammates who are
Catherine. Hi, I'm Kristen, and we're doing a really great project on the states of matter, water specifically. So we're going to look at water as a liquid, a solid, and a gas.
But not that kind of gas.
No, not that kind of gas.
A phase diagram specifies the physical state of a substance as temperature and pressure varies. At any point along the solid-liquid line, the phases are in equilibrium. Melting and freezing are occurring at the same rate. In other words, the same number of particles are moving from the solid to the liquid per unit time as are moving from the liquid to the solid. Similarly, at any point along the liquid-gas line, vaporizing and condensing are occurring at the same rate, which means that the number of particles moving from the liquid to the gas per unit time equals the number moving from the gas to the liquid. Finally, along the solid gas line, subliming and depositing are occurring at the same rate. That is, the same number of particles are moving from the solid to the gas per unit time as are moving from the gas to the solid.
Okay, here we have a phase diagram for water, showing the regions for solid, liquid, and gaseous states. This phase diagram of water is an isovolume diagram. This assumes a constant volume of matter so that we can relate pressure and temperature. There are many, many different types of phase diagrams, but this would be an isovolumetric diagram of pressure and temperature, or a PT diagram at constant volume, if you will. And it shows the temperature increasing to the right in degrees Celsius and the pressure increasing upward in atmospheres. The point being shown here on the blue line, which is the melting point or the freezing point of water, is the freezing point of water at 1 atmosphere and 0 degrees Celsius. It's also the melting point. And if you increase that temperature at the same pressure all the way to the purple line, which is the vapor line, water then goes from a liquid water state to a gaseous or steam state, gaseous state in steam. And at this point, the water boils. So you can see at the same, this is all, keep in mind, this is all at the same volume, but at an equal pressure, water can go from solid to liquid to gas simply by increasing its temperature. One other aspect about this phase diagram of water I'd like to point out is that the blue line, the freezing melting line, actually has a negative slope, unlike all other substances. You notice that the previous video showed the line having a positive slope, more of a Y-shaped, whereas this one actually has a negative slope, and the freezing point decreases as pressure increases. What this means is that water actually becomes less dense as it freezes and becomes in solid form, and therefore the solid form or the frozen form of water will actually float on top of its liquid form. No other substance can do this. If you take the blue point, the freezing point at 1 atmosphere and 0 degrees Celsius, you see that you can also, if you keep it at the same temperature, you can force it into a liquid state by increasing the pressure. And this is how ice skating works. You take an ice skate with a very small surface area with a few hundred pounds of pressure, or not even, go out on an ice skating rink and it will melt the ice underneath it, thereby creating a smooth, slick surface or membrane in between the ice and the ice skate, giving you a lot of friction-free lubrication, and it makes your ice skates go fast right across the ice. This is how ice skating works, with a constant temperature but increase in pressure, where water goes into the liquid state. Likewise, if you kept the same temperature and drastically decreased the pressure down to the purple line where it would become gas, you can actually boil water without adding any temperature to it. All you need to do is reduce the air pressure above the water surface, basically by putting it in the vacuum, and you could actually make water boil at a constant temperature without adding any heat at all. So this is a quick demonstration of some of the properties of water and the different phases that it can exist in. Hope this was educational, illustrative, and hope it was most enjoyable by everybody. Hope we didn't put anybody to sleep, and thank you for watching.